Principal for Richard here.
Hi, Dan.
Hey, how's it going?
Good. Just wanted to say hi. I'm not going to be able to stay for the whole thing, but just wanted to say hi, and I'll stay in for the first probably 20 minutes or so, and then I got to take off.
Okay, yeah.
Thanks for presenting to our students and to our, the ACI student group. Appreciate it.
Yeah, no, I'm happy to help out.
Let's get started. Welcome everyone to ACI General Meeting in Spring 2021. I hope the semester is going well for all the students here. We have an announcement. ACI, UIUC, and TNDI, we will have a joint workshop on April 7th, 6 p.m. in the same 2311 room and also by Zoom. So please feel free to join us virtually or in person. So it will be about 3D printing for beginners, and Jordan Owlett, a graduate student here in civil engineering, will give that presentation of the workshop. And with that, it's my pleasure to introduce Dan Gancarz from Applied Research Associate. Dan received a bachelor's and master's degree in civil engineering from University of Illinois, Urbana-Champaign. He's the registered professional engineer in the state of Illinois. He has been with ARA since 2013 as an on-site project engineer with Materials Group at Illinois Tollway. He supports design, construction, and construction reviews for material and pavements. He leads the Tollway's review and approval process for concrete mix designs. He is also involved with research and writing special provisions. He is member of TRB at ACI, and currently he is the president of ACI Illinois Chapter. We are so happy to have you here, Dan, today. If anyone wants to discuss more about ongoing or future work with Dan, please stay till the end. And if anyone has any question, please post it in the Q&A, the chat section, and Dan will answer that, or raise your hand and we can answer that. And you will have a time after the presentation to ask any question. So please join me to welcome Dan to give the presentation. Dan, the floor is yours. Welcome.
Thanks, Sachin. Let me share my screen here. All right, how's the presentation look?
Looks good.
All right, let me shift this Zoom video real quick. One second. All right, I think we're ready to go now. So good evening, everyone. I'd like to thank Sachin, Omar, and the ACI U of I chapter for inviting me to share my experience with concrete at the Illinois Tollway. I'll start off with some brief background info, and then the majority of the presentation will be focused on unique concrete projects and details on the tollway that I've been a part of. I'll wrap up talking about how it all ties to research. And finally, since this is an ACI meeting, I'll briefly touch on what is going on with the ACI Illinois chapter. So I'll start briefly with my background. Sachin went over my bio, so that kind of sums up a lot of it. So I was once where you guys are sitting today. I did my undergrad and master's in civil engineering at U of I. I knew early on that I wanted to focus on construction, and my interest in transportation and eventually concrete and concrete pavement engineering developed over the years. I was a graduate research assistant for Professor Raisler, and now I've been with Applied Research Associates since 2013. I started about a month after I finished my master's, and I work as an on-site project engineer with the materials group at the Illinois Tollway. This means that I'm employed by ARA, but I work full-time on tollway work and live up in the Chicago area. So with the tollway, I support design and construction reviews for materials and pavements with a focus on all things concrete. Since graduation, I've also been involved with the ACI Illinois chapter, eventually made my way onto the board, and this past year I've been serving as the chapter president. So a little bit about ARA, for those that aren't familiar. The company was founded in 1979. ARA as a whole has about 1,500 employees across the U.S. and Canada. The Transportation and Infrastructure Group has our main office in Champaign. The office is actually located just off the edge of campus near Memorial Stadium. ARA as a whole has a variety of business areas, including national security, infrastructure, energy and environment, and health solutions. I work in the infrastructure area, and that's the area we're going to be focusing on today. So focusing on infrastructure, ARA has numerous capabilities: airport services, pavement engineering, transportation asset management, just to name a few. ARA serves as the Illinois Tollway's infrastructure management consultant and provides services needed to ensure the implementation and updating of asset management systems, including pavement asset management, sign management, and maintenance management. So a little bit about the tollway. I'll start with a few basic facts. So the tollway is responsible for the construction, operation, regulation, and maintenance of a system of toll highways within northeastern Illinois. So here's a map of the tollway system, and for reference, let me find my pointer. There we go. So for reference, downtown Chicago is right over here on the shores of Lake Michigan, and O'Hare Airport would be right here. So the tollway is really, just in northeastern Illinois. So the tollway has 5 roadways that span 294 centerline miles across 12 counties in northern Illinois. We have the Tri-State Tollway, which is I-80, 294, 94, basically connects Indiana, Illinois, Wisconsin, why they call it the Tri-State. The Jane Addams Memorial Tollway, which is I-90, this is that east-west up here. We have the Reagan Memorial I-88, another east-west route. The Veterans Memorial, which is 355. And then one of the newer tollways, Illinois Route 390, that's going to connect to the future I-490, which is going to be the bypass around the western side of O'Hare. So the tollway system as a whole serves more than 1.6 million vehicles a day. Tollway is a state agency, but it is separate from the Illinois Department of Transportation. And finally, the tollway does not receive state or federal tax dollars to support maintenance and operations, meaning it's a user fee system. So only those that use the system pay for the system. So now that we have some background information, let's get into concrete at the tollway. As we go through this section, I'd just like to make everyone aware that the research and innovative ideas that I'm going to present are, not necessarily my original ideas, and there have been countless engineers and researchers, some in the room today, like Sachin, that have come up with these ideas and contributed to their success. A couple people I'd like to mention are Steve Gillen, who was the materials manager at the Tollway until his retirement in 2017, and Cindy Williams, who now leads the materials and pavements group at the Tollway. So here's a list of the concrete projects I'll be covering today: 2-lift composite pavement, performance specs, HPC, RCC, CRCP, some precast panels and approach slabs, as well as ultra high performance concrete. So the first two are closely tied to the I-90 reconstruction. It happened between 2013 and 2016. So this is at Jane Addams Memorial Tollway I was talking about, I-90. And this was a reconstruction and widening between 2013 and 16. The corridor as a whole was divided into 2 segments for planning, design, and construction purposes. We had the western segment, which is Elgin to Rockford, approximately 37 miles. And then the eastern segment was done in 2015 and 16, spanning about 25 miles from Elgin to O'Hare Airport. So some of the unique aspects of the western segment was the 2-lift composite pavement that was researched at the U of I, led by Professor Raisler and Dr. Alex Brand. The aspects of the eastern segment that I'm going to highlight today are the performance specification for the jointed pavement construction and the performance mix specifications. So these mix specifications became more commonplace around this time at the Tollway. So 2-lift pavements, 2-lift jointed plain composite concrete pavement with asphalt shoulders was used for most of the I-90 western segment. 2 different concrete mixes were used during construction. The lower lift mix that is being placed by this machine here includes coarse reclaimed asphalt pavement. And this concrete truck is placing a different mix that uses virgin coarse aggregate as the top lift. And then we have the paver here in the background that is consolidating and finishing both lifts into the finished pavement, and then followed up by the standard cure time machine. So here is a core from that pavement. The concrete mix for the top lift required virgin coarse aggregate, while the concrete mix for the bottom lift required 15 to 50% replacement of the coarse aggregate with coarse reclaimed asphalt pavement. Those are the black aggregates here. You can see in the core. So the bottom lift concrete was commonly referred to as black rock concrete because of that coarse wrap. The bottom lift also required Portland cement concrete replacement with SEMs, fly ash and slag. Total replacement percentage was between 35 and 50%. So the other thing this core shows is, a well-consolidated top and bottom lift as it went through that paver. These mixes are placed, what we call wet on wet, right after each other. So we're looking for, full bond between the 2 lifts, and you can't you can't really even see a bond. Oh, it's a full bond on this core here. And the other thing we're looking for is, minimal intermixing between the two lifts. And, this core is a good example of, two distinct mixes, but that are more or less monolithic. So that was the western segment of I-90. Now in the eastern segment, the focus was on performance-related specifications. And the jointed pavement that we built in 2015 and 16 was built with a performance-related construction specification. So the idea behind this specification was to compare the as-constructed pavement to the design and incentivize the contractor if they built it better than design, or disincentivize if the quality was lower than designed. So for that pavement, we had 5 acceptance quality characteristics in the tollway specification. So this included compressive strength, air content, concrete thickness, surface smoothness, dowel bar alignment, and each of these acceptance quality characteristics had 3 levels, a target level, a rejectable level, and a maximum quality level. So the target quality represents the as-designed pavement quality, and it's the quality level where the contractor would receive 100% pay. The rejectable level represents the minimum quality that can be accepted before corrective action or retesting, reduced payments, or removal would apply. And then finally, the maximum quality level represents the level where no further incentive is achievable. And any pavement that is above the maximum quality level was paid at the maximum incentive. And I'll show a couple examples of the strength and thickness pay factor curves coming up here. So this is a plot of the strength pay factor. These curves are calculated using life cycle cost assessment. And for strength, higher quality here is defined by increasing strength. The multiple lines are for different standard deviations of the data, and similarly there, higher quality is defined by decreasing variability through the standard deviation. So these values were included in the specification and are unique to the 13-inch jointed pavement that we built on the I-90 corridor. And linear interpolation was used for strengths and standard deviations that do not fall on these curves. But as you can see here, the target was standard deviation of 500 psi and 5,500 28-day compressive strength. And then if they increase the strength, that was an incentive. Decreasing was seen as a disincentive. And then as you reduce your standard deviation, that's also seen as being beneficial. So on all these factors, we had these curves with the pay factor on the y-axis and on the x-axis, the characteristic we were looking at. And here's another example. This is the values for the slab thickness pay factor. Notice this one looks a little different than the strength. The as designed target thickness for this pavement was 13 inches. And you can see, get my pointer here, a small reduction in thickness results in a significant decrease in service life, as well as an increase in standard deviation. But conversely, that same increase does not result in the same increase in service life. And this ultimately has to do with the pavement design for that section and the various factors that go into that pavement design. And then just to wrap up on, this performance construction spec, composite pay factor for the lot was calculated, and it used each of these individual pay factors, and they all had equal weight. And the Tollway selected a maximum incentive of 105% and maximum disincentive or minimum of 85%. All right, so just talked about the performance-related specifications for jointed construction on I-90. And this kind of takes us more to focus on concrete mixture specifications and the performance-related specifications for those. So the Tollway has 5 mixture types, and they are designed for specific applications. Both Tollway and IDOT mixture designs can be specified on Tollway construction projects. And this is just a list of all the mix types that can be used. I'm not going to go into the IDOT ones in detail today. But these are the Tollway mixture types. So Class TL is the mixture used for pavements. Class AX is a Portland cement-based high-early strength patching mix that can be used in both pavements and structures. 2,500 PSI is our opening strength for pavement patching, and the AX mixtures can usually achieve that in about 16 hours. Class CAL is relatively a new mixture type. It's used for very high early strength patching and uses calcium aluminate cements along with a latex admixture. The Class CAL mixture can easily achieve the 2,500 PSI opening strength in about 4 hours. Class HP is our high performance concrete. It's designed to resist chloride penetration while mitigating shrinkage that can cause cracking. The Class HP mixture is currently used for bridge decks, approach slabs, transition approach slabs, and moment slabs. And finally, we have Class MC, our mass concrete mixture. This is used for structural elements that have a minimum dimension that exceeds 5 feet. So there's limits on the temperature differential as well as the maximum temperature. So for these Tollway mixture designs, we have 5 primary goals, and these are in no particular order. Strength, we need to have adequate strength for the application, but we don't want mixes that are excessively over-designed. Durability, the climate in Illinois presents challenges in achieving long-lasting concrete, but it definitely can be done. So, we focus on freeze-thaw resistance, mitigating shrinkage that could lead to cracking, improving chloride penetration resistance to delay corrosion, and then also proportioning mixtures to prevent ASR. We also look at place focus on constructability because a mixture that performs well in the lab won't necessarily be able to be consistently batch placed, consolidated, finished, and cured in the field. We also have a focus on performance, and the concrete producers, material suppliers, contractors that serve the Tollway, they themselves have a wealth of concrete knowledge and expertise. So having a performance focus allows the Tollway to reduce prescriptive requirements encourage innovation, lower costs, increase durability of concrete structures and pavements. And then finally, sustainability. We try to include recycled and byproduct materials in tollway concrete to improve or, at least maintain our current level of quality. So as I mentioned, we try to focus on performance with our tollway mixtures. This is a list of test methods that are required. Our higher end Portland cement mixtures like AX, HP, and mass concrete require the most testing. The test limits for each of these mix types can be different depending on, how the mix will be used. So now that we talked about concrete mixtures as a whole, let's dig into a little more of the details of HPC. So here is, here's an example of the testing requirements for a Class HP mix. We use the Class HP high performance concrete mixture for bridge decks. It's designed for 4,000 PSI at 14 days. It requires freeze-thaw or hardened air, a slump loss test, linear shrinkage, ring shrinkage, chloride penetrability, and then has some water cementitious ratio tolerances during production. And so, the bridge deck mix and the Class AP, we're really focused on mitigating shrinkage cracking because it's used for bridge decks. And that's usually achieved, the shrinkage mitigation, through either optimized proportioning and shrinkage reducing admixtures or lightweight fine aggregate for internal curing. But here's another option we're exploring. The Tollway has an active research project on super absorbent polymers in concrete to improve durability. So this project was started in 2019 and will wrap up at the end of September. This research includes testing on the set material itself and then evaluating its effect on HPC when used as an internal curing agent. So there have been some interesting findings in the lab work, and the research team led by Professor Lang is planning a field test section for the end of April. Actually, ACI Illinois will be having a virtual chapter meeting on April 22nd, and we'll be welcoming Professor Lang to present the latest findings of this research. Moving right along, the Tollway did use RCC in 2014. Very familiar with these projects. So it was used for truck parking lots at 4 Tollway Oases. And if you're not familiar with a Tollway Oasis, this image here on the right is the typical layout. There's an over-the-road structure. You have gas stations. You can access this from both directions, but and then as well as parking lots. So you have car parking lot and then truck parking lots. So these truck parking lots here are where we use the RCC. And this one, basically 3 out of the 4 projects had a asphalt overlay on the RCC just to have kind of a better finished surface. So here are the pavement designs that were used. Like I said, 3 of the 4 sites had a 2-inch asphalt surface on 8 inches of RCC. The Des Plaines Oasis was unique because it was a shorter life pavement, so we didn't use the asphalt overlay and the pavement was a little thinner. All right, so one of my favorite topics, CRCP. So recent work within about the past 5 years at the Tollway has focused on some what I would call CRCP innovations. The first two projects here are the Illinois Route 390 test sections and the Precast CRCP were projects that were spearheaded by Steve Gillen. I was involved with these projects along with some more of the recent work on cast-in-place patching and CRCP widening and modification. So I will first talk about the Illinois Route 390 test sections. So the Tollway funded a research project to investigate innovative structural and materials designed for CRCP. The project looked at methods to build a more cost-effective CRCP by considering how an internally cured pavement mix would impact crack spacing and width, also pavement thickness and percentage of steel. This work was conducted by Professors Raisler, Weiss, and Zollinger. And as part of this research project, the Tollway built 9 3-lane test sections on the greenfield construction section of the Illinois 390 corridor in 2016 and 17 to test out these new ideas. So this photo here is just from one of the paving days, and you know, it's one of my I'd say favorite photos from the project. So I did come across these photos when I was putting together this presentation. Some of the grad students in Professor Raisler's research group hard at work during the test section construction. So I will say that I was impressed with Sachin, Omar, and the others were never afraid to work long hours and get their hands dirty, as you can see here. All right, so let's see if this will work. This is, yeah, all right. So ARA took a drone video from one of the main test section paving days. So this gives a good overview of paving of 2 of the test sections. Each of the test sections were approximately 500 feet long. This is 3A and 3B. We used uncoated reinforcement where we would usually use epoxy coated. Here the contractor is paving the internally cured mix 2 lanes wide using a placer spreader and paver followed by the cure pen machine. We use a different internally cured mix for each of the 500-foot sections. Section being timed here had macro fibers. Some of the other unique features, there's a end treatment here, which is a different design from the typical lug system or wide flange beam. And finally, as we get to the end here, you can see these cones. And those are the locations of the various sensors that were embedded in the pavement. All right. Oops. Okay, here we go. All right, so the next project is also CRCP, but mainly focuses on precast patching and weighing motion on the tri-state tollway. The precast CRC, this was a joint effort by Steve, Shiraz Tayabji, and myself. So here's a Google Street View of the project site before the patching. There was a weigh-in motion system in CRCP that was no longer operational and caused distress in all lanes. High traffic volume in this area required an overnight solution to maintain the same number of lanes during the day. So the patching was performed in October 2017, utilizing precast panels for CRCP repair. So the multi-lane night operation, like the conventional jointed precast panels, but it was complicated by the desire to maintain longitudinal reinforcement continuity. So the first night involved marking patch limits and saw cutting. The second night, pavement removal began once we had the lane closure set. After the existing pavement was removed, the base was recompacted. We added aggregate if necessary, so that the gap underneath the panel wouldn't exceed an inch. The contractor then drilled and grouted number 10 rebar into the existing pavement. And this was done to maintain the continuity of the longitudinal reinforcement once the repair was completed. So also night 2, backer rod was attached. This is used to contain the undergrout under the panels. And then the panels were delivered the night they were set. So also wrapping up that same night, panels were set continuously. The panel at the left there is a temporary dummy panel that was needed to open the roadway to traffic, since we couldn't get everything done in the second night that we needed to. The permanent panels were set on leveling bolts and undergrouted, and after the grout achieved strength, the leveling bolts were removed and panels were opened to traffic. So on the third night, the temporary panel was removed. That splice zone was backfilled with a rapid set cast in place material. For this project, we tried a high early strength UHPC mix and also a steel fiber reinforced CTS rapid set DOT concrete mix design. And you can see kind of the difference in this picture. This mix here is the UHPC, and these two here, I believe, are that other rapid set mix. And then once we were done, the entire area was diamond ground for smoothness. So briefly touched on that. Precast CRCP. If you'd like further details on this project, there's an FHWA tech brief. There's also an article published in Concrete International in October 2018. So check those out. And then just downstream of the Precast CRCP, another innovation involved adding weigh and motion equipment to the precast panels. So these panels were installed across all 5 lanes in February 2018. Each precast panel was 14 feet long and had that similar 18-inch cast in place splice zone on each end. And then all the weigh and motion equipment, including vehicle detector loops, 2-quart sensor elements were embedded in the precast panel with wiring run to the shoulder. So this eliminated any saw cutting in the surface of the pavement, which that type of installation of saw cutting it into the surface was what led to the distress where we used those other precast panels. So this is the finished product. The photo on the left is the Precast CRCP weigh in motion in May 2018, shortly after construction, and the photo on the right was taken about a year ago. The system's performing well, and the tollway is actually planning on installing similar systems on 355 and a different, actually north end of the tri-state. But the main difference there is we will be using, we'll be putting these panels in jointed pavement instead of CRCP. So the design and the connections will be a little different. And then here's just a recent near map aerial of both precast sites. So the CRCP patches, the precast, replaced the distressed WIM and pavement there. And then the new WIM was installed in precast panels, a couple hundred feet downstream, to mainly give this new pavement the best shot for long-term performance. And then we dime and ground the entire area for smoothness. So both of these repairs are performing well. So we used UHPC for those precast CRCP system, but there have been a couple more recent uses. So, ultra high performance concrete UHPC isn't necessarily a new technology. It's commonly associated with accelerated bridge construction, but recently it has been gaining interest in Illinois and elsewhere for rehabilitation use, such as UHPC bridge deck overlays, and UHPC for bridge preservation and repair is currently an innovation in round 6 of the Federal Highway Administration's Everyday Counts program. So this year, the tollway is using UHPC to fix bridge joint headers on 355. And that's this picture here. You can see there's a temporary asphalt patch in here. And this, this is the joint between the bridge and the adjacent pavement. And this is kind of a, a highly prone to distress. So we think that UHPC would be a good option to patch the concrete in this case. So the project's specific special provision requires compressive strengths of 12,000 PSI at 12 hours and 22,000 at 28 days, which is pretty typical of UHPC. Among other, mixture requirements, this is just, highlighting the strength requirements. And then, like I said, we've used UHPC for the precast CRCP connections. We've also experimented with it for partial depth bridge deck patching, and we currently specify it for our precast approach slab connections. And speaking of precast approach slabs, the tollway actually just wrapped up a research project to investigate early age cracking in cast in place approach slabs and feasibility of full depth precast approach slabs. So this image here on the right is an example of the cracking that was being seen. And the tollway's approach slabs are 30 feet long by a lane width, and they're on both sides of the bridge deck. So, in this illustration here, the bridge deck's omitted, but, you'll have a set of approach slabs on both sides. So this research was conducted by the University of Illinois by Professors Fonstock and Lefebvre. So precast approach slab fabrication. These precast approach slabs were, one of the more interesting parts of the project. Here's one of the shoulder slabs being cast at the precast facility. This also is one of the slabs that the research team instrumented. So all this red wiring is, going into the slab for their embedded gauges. And then the precaster also used self-consolidating concrete for these slabs. So the slab installation was also exciting to see since these slabs are quite large and we needed a large crane. And then, here's kind of the finished product. These were the slabs that were instrumented. So all the wiring was coming out of this joint here, which is an expansion joint, and then the grad students got everything hooked up after the fact. So I've just touched on most of the concrete projects I've been involved with over the past 8 years at the Tollway. I've also highlighted some of the Tollway research projects that have been led by U of I. And I think this shows the importance of research, new ideas, and innovation. So in my experience, I see applied transportation research being tied to project design, construction, and ultimately maintenance, and it following a cycle like this. In the case of the Precast approach slab project, there were maintenance concerns with the early age cracking. So the research looked at factors we can change in the design as well as the construction phases to ultimately reduce and eliminate the cracking. And sometimes the design phase generates the research, like in the case of the U of I CRCP research project. There was an interest in designing a CRC pavement that was more competitive on initial cost basis. So it was really, looking at the design aspects. Also, construction experience can generate research, like in the case of the super absorbent polymers. We're looking, for more options in construction to meet those performance specifications. So as you can see, the Tollway does sponsor research since 2014. This has, the Tollway's research has been done through the Tollway's research program. And this isn't, necessarily an official mission statement or quote, but I think it pretty concisely captures the program's goals. To identify, fund, execute, implement research that has a positive return on investment and assist the agency in meeting its overall goals and objectives. And one of these key words there for me is, implement. So in my experience with the Tollway, there's a strong interest when identifying research needs that they need to be applied research that can be implemented. And in my role with the Tollway, I help with research project management, including things like constructing test sections, and then, at the end of research projects, helping to implement the research findings. And here is a list of the research projects that have been funded by the Tollway's research program. I've highlighted the concrete-related ones today, but the others go beyond concrete. There have been projects on, light poles, intelligent compaction, asphalt, environmental aspects, traffic management, and then, one of our more recent ones on basalt fiber reinforced polymer rebar for use in bridge decks. So on the Tollway's website, you can sign up to get on the email list. That would be this box right here, to hear about future research opportunities with the Tollway, and I would encourage you to do that. And finally today, I want to give an update on the ACI Illinois chapter. So we're currently doing virtual meetings. Our next one is actually on April 22nd, like I mentioned, with Professor Lang presenting on the benefits of using super absorbent polymers in concrete. The registration link is here, and there's more information on the ACI Illinois website. That's aciillinois.com. Our final virtual meeting for the spring will be on May 20th. And that will be a ACI chapter talks on low compressive strength test results. And I know we've had students attend these virtual meetings in the past. They're free, and I'd really like to encourage everyone to attend these if you're available. And then looking forward to the fall, we're hoping to be able to return to our in-person dinner meetings. These dinner meetings are held monthly in the Chicago area. From September to April, we usually have a joint meeting with the U of I chapter in early April. Obviously, we're not having that right now this year, but we decided to push that to the fall so we can hopefully have a normal dinner and presentation in the Crane Bay. The ACI Illinois chapter also hosts fiber reinforced bowling ball competition every year with universities and industry. That will either be rescheduled for the fall or we'll have it on its normal cycle, which is usually January, February of each year. And then one other thing to note, we're also planning on bringing back a student scholarship. So, I think this highlights the many opportunities for students to get involved with the Illinois chapter. And if you need any additional information, on anything that I discussed today or the ACI Illinois chapter, feel free to reach out to me. So with that, I'd like to thank the ACI U of I chapter again for inviting me to share my experience, and I'd be happy to take any questions.
Thank you, Dan. Yeah. If anyone has any questions, please feel free.
I have a question for you, Dan.
Sure.
I'm mainly working on RCC materials, and I was wondering what kind of work you did with that for a tollway.
So yeah, the Tollway's RCC project, like I said, they were truck parking lots, and so the Tollway had a spec that they basically created for that project, and so my involvement was kind of support with refining that specification because from my time at U of I, working with Professor Raisler and taking some of his classes, I also got some experience with RCC. So I had a good idea of kind of what I was looking for, and so I was involved at the specification side, and then also the construction inspection side, because RCC was something that was new to not only the Tollway but IDOT. So the contractors that were doing the work, didn't necessarily have a whole lot of experience. So it was mainly providing technical support during design and construction.
Okay, and how did it turn out? Did you do like a survey on that, or? Yeah,
so it's so those three projects that had the asphalt overlay, I have, we haven't done kind of a formal surveyor report, but I've been going out to those, in my travels along the tollway, and those are performing well. I think one thing to note, I believe we did, in the RCC, we saw joints at 25-foot joint spacing. But then in the asphalt overlay, we did not saw and seal joint. So, as expected, we saw those joints reflect through, but, they're performing well. So those lots are performing well. The one that we did at the Displays Oasis that didn't have the asphalt surface, there were some challenges there, just with it being the finished surface. Mm-hmm. And we also had some challenges with the time of year that we constructed it. One area was built in, I think it was late November, early December. And, cold weather concrete in general, presents some challenges. And then, add RCC to that. And we saw some issues there, but I think overall, you know, the experience was positive. And, you know, RCC is definitely a good tool to have. You know, I don't think it's, you know, appropriate everywhere, but it's a good option to have.
Okay, thank you.
I have one more question. So, like, you know, you talked about the diamond grinding, especially after the precast concrete is placed. So once diamond grinding is done, like, is the tining like gone, or like how do they maintain tining or the advantages of tining after diamond grinding is done?
Yeah, that's a good comment. So the diamond grinding itself produces, you know, what they call like a corduroy type pattern. So it's similar to tining, and I think the friction characteristics of it are, you know, pretty comparable. So, you know, in a situation like that, you know, where we're diamond grinding, you know, an older pavement to kind of restore the smoothness, it does take away the tining that was there for initial construction, but the resulting surface that the diamond grinding produces does have sufficient friction. So there's not really anything you have to do, you know, besides the diamond grinding after that.
I'm gonna kind of continue off of Sachin's question with the precast panels for the CRCP. It looked like for the way of motion slide that you showed, to me, it just looked like that would be kind of a, not a nightmare, but a pretty hard kind of fit merging that precast panel, because it just looked like you just had slots in there, and then the adjacent panels already had the tining, or not tining, the bars sticking out. I don't know if you guys ran into any issues with that particular application, because also I was kind of just thinking about the sensors and the actual weigh in motion device beneath. If you were kind of setting the slab down and then sliding it into place, if there was any issues regarding that.
Sure. Let me actually share my screen again. And it's kind of funny because, yeah, there are definitely challenges with precast pavements. And let me, okay, so with the weigh in motion, you know, this one, the CRC precast was actually almost easier for the tolerances. And I say that because, you know, these precast panels are usually the full lane width. And in this case with CRC, if I go back a couple slides, we do have these closure pores. So if they're not exact, you know, you can make it up in the closure pore. With the jointed system that we're going to be doing next year, or, you know, we're designing it right now, you basically, you know, cut the hole to fit the panel. So that is, you know, definitely a tight tolerance. And just on other projects, you know, not necessarily the CRC precast or weigh in motion, that has been an issue with, you know, contractors either cutting the, you know, the hole too big or too small, because we only allow a 1/2 inch tolerance on either side. So in this case here, you know, the crane is setting that panel, so it's going to swing it over and then drop it into place. And then, yeah, like you said, kind of pulling this cabling through the conduit. While doing that, it adds, you know, it definitely adds a level of complexity. But ultimately, you know, I think you know, we were able to achieve it on this project, and it can be achieved as long as, you know, kind of all stakeholders are, you know, communicating ahead of time, planning things out. You know, it can be done, but it's definitely not, you know, as far as concrete patching goes, this is definitely at the complicated end of things.
Thanks.
Sure.
As far as fibers used in pavements is concerned, you see a point in the future where it will just become commonplace, common practice to just add fibers, microfibers, that is, synthetic ones, they're easier. As part of the usual mix design, and the exception is sort of not adding them in cases such as CRCP, etc.
Yeah, that's a good comment. I think fibers in general, you know, over my time, over the past 8 years in industry, they've definitely become, you know, they've been more researched, become more commonplace. You know, we see them in, you know, concrete overlays, and, you know, we use them in the CRC test sections. And I think they did provide a benefit. So, you know, that being said, I think it does kind of all come back to, you know, the ultimate cost of it, you know, kind of that cost benefit analysis. You know,
Sure.
Would they, you know, be a benefit to, let's say, regular jointed pavements? You know, they're not going to hurt it, but at the same time, you know, I think as we become better able to quantify those benefits and, you know, provide that, you know, cost benefit analysis, that, yeah, we'll probably see fibers more often in pavements.
So I have a question about the pay factor percentage. Like, so it goes up to 105 in the upper limit and down to 85%. Like, how often do contractors get up to 105%?
So yeah, that's a good question. So on those I-90 construction projects, we actually saw the majority, the vast majority were either at or above 100%. So I think there was maybe, you know, it was, that corridor was broken down into probably about 12 different contracts. I think only maybe one of the contracts got that 105%. Because, you know, if you look at those pay factors, you know, there are certain things that influence it more than others, you know, like I was saying with the thickness, and just, you know, intuitively from pavement engineering, you know, it makes sense that, you know, if you have a properly designed pavement, if you're building it thin, you're going to see a drastic reduction in pavement life. And so, you know, we pretty much saw all contractors, you know, paving it to get the maximum incentive on thickness, and then, you know, just being cognizant of the other requirements. But they actually, you know, performed very well overall. And like I said, they were all, you know, at 100% or above 100%. Any other questions?
I think that's all we have. Thank you so much, Dan. Thank you so much for the presentation. It was very informative, and thank you for taking time and presenting to us. We also look forward to meeting and having a joint ACI dinner in fall once things start getting in person. Thank you.
Yeah, you're welcome, man. Now I'm looking forward to coming back down to U of I in the fall and you know, having that joint dinner too. So if I don't see you before then, you know, I'll see you guys in the fall.
Sounds good. Thank you so much.